Good day. Yeah, this is the last lesson for standard form. In this lesson, we will demonstrate the use of numbers presented in standard form in real life situations. The example that you have, the distance between 2 points is 2.54 times 10 to the power minus 2 meters. Express it in kilometers. We know that 1 kilometer is 1,000 meters. And we know that if we are given a distance in meters, if we want to convert it to kilometers, we simply divide it by 1,000. So that's what we are going to do here. We'll divide that number which is given in standard form by 1,000. But since we want to skip our lesson on the use of numbers in standard form, let's also express that 1,000 in standard form. It becomes 1 times 10 to the power 3. Now we use our previous example to calculate that division. So we'll have 2.54 divided by 1, closing brackets, times 10 to the power minus 2 minus 3. We did this from the previous lesson. If you skipped that, I think you need to go back to that lesson. So our answer becomes 2.54 times 10 to the power minus 5 kilometers. Okay, I won't correct that. I made a mistake. They're supposed to be kilometers, not meters. Make that correction there. Mount Everest, the highest point on Earth, is 8 points above sea level. The lowest point is that much below sea level. So we drew 3 points there. The center one is the sea level. We denote it with 0 meters. And then Mount Everest, the most point, is 8.48 times 10 to the power 3 meters above sea level. Now that place, Mariana Trench, is 1.103 times 10 to the power 4 meters below sea level. But we are required to find the vertical distance between the lowest and the highest points on the Earth's surface. So the distance between those 2 points, you will realize that we simply add those two numbers and they are expressed in standard form. How do we add numbers in standard form? We did that in a previous lesson. You break down back to their original format, or decompose them back to their original format, and then do the addition, whether you use a calculator or manually. Then the answer that you get, 19,878, express it back to standard form, which becomes 1.99 times 10 to the power 4 meters. That is it to 3 significant figures. Now, our last example, the diameters of the Sun and Earth are approximately 1.4 times 10 to the power 6. There is the Sun, is the moon, is the Earth, and then the Sun is bigger than the moon, the Earth, obviously. And then the other one is 1.3 times 10 to the power 4. That's the Earth. We want to find the ratio. How many times larger is the diameter of the Sun compared to that of the Earth? We simply divide diameter of the Sun by the diameter of the Earth. 1.4 times 10 to the power 6 divided by 1.3 times 10 to the power 4. So this one, I think for now it's straightforward. 1.4 over 1.3 times 10 to the power 6 minus 4, which becomes 1.07 times 10 to the power 2. That's, yes, it's a ratio, so there is no units there. Thank you very much. I think we are done with this part of standard form. We will move on to the other section, but we are still on general arithmetic. You can do more exercises from your textbook, whatever textbook that you use, so that you understand. The more you do, the